In a galaxy, in the far reaches of the universe, a planet on the distant arm of the Milky Way is where Gooby lives. Hello. Today, I'd like to talk about our place, meaning humans' place on the planet we live. There's a really cool video taken from the International Space Station. It's available for free. It's on, you can find it on Wikimedia Commons, where there's lots of videos that are copyright free. They're in the public domain that you can look at for free and use if you want in videos. This is our planet. This looks like a desert here, but it's an hour-long video. It's actually very relaxing to look at. Not sure where this is, but what's really cool about the Earth is a lot of it is covered in water. I forget how much of the Earth is covered in water. I think it's like 2/3. That's interesting because like 2/3 of the human body is water, I think. But wait. Here you can see parts of the International Space Station, and you can see Italy, but it's upside down. It's an upside down boot. You can see the sun reflecting off the ocean. Pretty miraculous that humans have been able to go up into space and take video of the Earth that we live on. I mean, that's pretty cool. Send up satellites and stuff. But there's something about the way we view. I'm gonna stop this for now. Oh well, first we're gonna try to find the prettiest part. Oh yeah, look at this. These are these reefs off of the Bahamas, Bahamian Islands, and the sand is built up there. It's beautiful. It's gorgeous. Lots of life in the oceans. Well, the topic of today is how humans think that we're the center of everything, but we're not actually. And so the other title of this video is Planet of the Tardigrades and Tubeworms. There's some movies called Planet of the Apes. I haven't watched all of them. These days there's a lot of for some reason people just keep wanting to make sequels of popular movies, because I guess that's a sure bet financially or something. But I could just get kind of tired of like Fast and Furious 30, where they're like geriatrics racing around in hot rods. But I've watched like the earlier Planet of the Apes movies, and it's kind of cool. It's like after humans have been nearly wiped out, and apes have taken over. But it's funny because humans are apes. We're just one of many different kinds of apes. But Planet of the Tardigrades and Tubeworms is very different. We are not tardigrades or tubeworms. And you may say, Gooby, what the heck are tardigrades? Well, that's why I wanted to make this video, because I learned about tardigrades recently, and they are very cool, in my opinion, and that's why I wanted to share them. So here is a video. Here's a video of a tardigrade. I've named this one Bob, and Bob has a friend named Kevin. here. They're also called water bears. But tardigrades, they're really cool animals. So they're animals like you and me. They have eyes, they have a brain. They don't have a spine, but they have a neural cord. They actually have 2 neural cords that helps move these legs with claws on them. They're only a ½ millimeter long. I mean, a millimeter is very tiny, so a ½ millimeter is even tinier. They have a mouth. They poop. They have sex. They make babies. They crawl around. These animals are really cool because they're located everywhere on the planet of Earth. They really like moss and kind of wetter areas. They're called water bears, but they can live in dry areas too. They can live in deserts. They can live up in mountains, like the ice cold top of the mountains. They can live down deep in the ocean, like at the bottom of the ocean, where the pressures are incredibly intense. And people have taken these tardigrades up into the International Space Station, where we saw the video of Earth, and exposed these animals to the outer space, to the vacuum of outer space, and the intense solar radiation of outer space, because our atmosphere protects us from a lot of radiation. But these animals still survive. They are so tough. Then they're everywhere. Like, you just go outside, and if you had a microscope, you could just take some water off of like a leaf or grass or moss, and then look at it under a microscope. You'd probably see one. There's probably a couple every square centimeter. So they're pretty cool. They're so tough that I think they could survive a nuclear war. Like if humans, which we're very smart, but I don't think we're very wise. I don't think we're very wise. If we have a very big nuclear war that wipes out pretty much everybody and irradiates the whole planet, or when civilization completely collapses, if we don't safely deactivate the older nuclear reactors, they will melt down and explode, and then the radiation will enter the atmosphere and the water cycle and irradiate everything on the planet. But these animals will probably survive, the tardigrades. And I don't even think they really know about us. I don't think Bob and Kevin think about humans. I think they're just nom-nomming on green stuff, having sex, talking to each other. That's it. I don't think they really know about us. I don't even think their eyes could focus on us because we're so big to them. So when we're gone, I think the planet will still have tardigrades. Now, I'm going to talk about why we might be gone. But there's one other animal that I think would also still be here when humans are gone. And that is the Deep Sea Tubeworm. These are worms that live in these tubes, so they're called tubeworms. There's the red right here, and then the white is the tube. And then they have these other things that I don't know if they're the same creature or another creature that lives in the same area. They look really funky. These are sperm packets, so they're actually sexually reproducing. There's sperm packets floating in this hot water. You can see how hot the water is on the left. They live next to geothermal vents. This video is taken from. This video, I'm going to put it on loop. This video is taken from. Oh, you can see the hot water coming out of a vent on the very bottom left there. nutrient-rich water. That's what these worms are eating and living off of. And they live in complete darkness because it's at the very bottom of the ocean, far away from most other living things. They don't need the sunlight. They just survive off the heat and nutrients coming out of the Earth's crust, metal. They don't need light. They don't have eyes. They're just living, making babies, making more tube worms. I don't think they know what humans are either. Well, these may know. These have experienced a human submersible with its bright lights, but majority of tube worms down there never seen a submersible of a human. They probably have no idea that humans exist, and they don't really rely on a lot of food sources that a lot of other animals survive off of. So I think that tube worms will survive after humans are gone. So that's why I think a better name is not Planet of the Apes, because I think apes are probably going to go extinct. I think a better name is Planet of the Tardigrades and Tubeworms. Now, some people, including my parents, are like, yeah, Gooby, Gooby, you worry too much. You worry too much. People have always thought that the world's going to end, like from the beginning of time. Well, humans haven't been around since the beginning of time. But during humans' existence, which has been about 300,000 years, or 0.3 million years. That's about how long modern humans have been around. We have never had a mass extinction event. There have been 5 previous mass extinction events in Earth's history, and we are in the midst of a 6th one that's largely started by humans. And I'm going to talk about that for the rest of this talk, but before I do, I have to make some things clear. Some people say, Gooby, I can't believe you fell for the globalist agenda to control you and make you live an austere life while they soak up all the resources and live an extravagant life. Well, okay. 2 things can be true at the same time. There can be people in the world that are very greedy and want to take everything for themselves. We're seeing that in this country where I live. Very rich people want more wealth for themselves, and they want to make everyone else live a tougher life. Yeah, I agree. But it is also true that science can figure out a lot of important things. It can't figure out everything. I've talked about that. Science cannot really understand consciousness, because you have to use consciousness to understand consciousness, and that's very hard. But science is very good at figuring out a lot of other things, including how the climate works and how physics and thermodynamics and energy and biology and ecology work. And just because it makes somebody feel uncomfortable or hurts their feelings doesn't mean that the science doesn't still exist and that reality works that way. If someone wants to bury their head in the sand like an ostrich, well, they can, but it doesn't change the physics of the sand that they bury their head in, and the air and the sunlight and how everything else works. They just stuck their head in the sand. So, in talks like this that make some people feel uncomfortable, because it's an uncomfortable thing to think that we might die and we might go extinct. There's a number of things that people do to attack the person who's talking about it. But some of the things that people have said when I've talked about things like this is that I've fallen for a globalist agenda. Not true. Not true. Yes, there are people that are very greedy and want to control everything. it doesn't change the fact that this is scientifically what is happening. And then some people say, well, I can't believe you still believe in science. You've said even in your own videos that science can't understand consciousness. Again, two things can be true. Science is really good at figuring out some things, not everything. It's really good at figuring out how the climate works, how the sun's energy is interacting with all the gases in the atmosphere, a lot of them that we've burnt from fossil fuels, oil, coal, and natural gas, releasing CO2, methane, and other gases called greenhouse gases that trap heat in our atmosphere. Those are the two things I wanted to clear up before we go into this discussion. Actually, before we talk about this mass extinction, I gotta show what's happening to the oceans, and then you can understand. Then we can segue into this. So we're gonna come back to this. There is a very cool website called climatereanalyzer.org. Climatereanalyzer.org. It is run by National Science Foundation, Climate Change Institute, University of Maine, and a lot of the data is gathered from satellites from NOAA, National Oceanic and Atmospheric Administration. A lot of this information comes from federally funded science organizations. And unfortunately, at this time in my country, well, in the country, not my country, in the country that I live in, that I'm a citizen, I don't own this country. I am a citizen in the United States. I was born here. I have lived here my whole life. I am not from some other country. Don't tell me to go back to my country, because I am in my country that I was born in. So, yeah, that's a bunch of BS racist stuff if someone says that. I am in my own country. This is where I grew up. So don't tell me to go back to China or something, because I never was born in China. That's a bunch of baloney. It makes me so mad. In this country where I live, a lot of federal agencies are having their funding cut, and people are being laid off. Thousands and thousands of federal workers are being laid off. And it's upsetting, because there's a lot of things that are important that everyone needs. I mean, just a very basic thing that I think everyone can agree on is that our national parks are really cool. There's beautiful wild lands that are taken care of by park rangers. The park rangers take care of not only the plants and animals that live in the park, but they take care of the people that visit the park and help them be safe and rescue them if they get in trouble, and make sure that people are not hurting each other in the park. Well, a lot of park rangers are losing their jobs, and that's making the parks harder to keep open. There's trails where I live that are closed because they don't have the staffing to keep them safe, and so you can't even go to these trails. I think everyone can agree that our wildlands are beautiful and we should be able to enjoy them, but we're currently losing that. I don't think anyone would say, oh yeah, we need to get rid of our beautiful natural wildlands. I don't think anyone would say that. Well, except for maybe an oil company that wants to drill oil underneath a national park or something. But this website is, a lot of the information is gathered by a national federal science administration. So I hope that this website continues to function, but it may not. So I'm going to show you what this website shows just in case it gets shut down for some reason, or the data that goes into this website that's updated every day, somehow the flow gets interrupted or shut off. So this website is really cool. It's called Climate Reanalyzer. And there's two things that I check on this at least a couple times a week. One is the daily sea surface temperature. So on the daily sea surface temperature, it shows records back to 1981. And it shows the temperature of the oceans from 60 degrees north to 60 degrees south. So on a map, it looks like this. From essentially this black line, which is like top half of Canada, Scandinavia, and Russia, down to past the tip of South America and Australia and New Zealand. So it excludes the very North Pole and Greenland, top of Russia and Antarctica, and top of Canada. But it measures the water temperature at the surface across this huge, vast part of our globe. And it does that by satellite, and it records the temperature average. And this is very interesting because water is a heat sink. Water can soak up a lot of heat. Ice melting soaks up a lot of heat. And the reason why I'm talking about the ocean temperature now is because it helps, I think, understand what kind of situation we're in. That's what I'm going to talk about. Here is the ocean temperatures. At the equator, they're warmer. That's red. It's warmer water because the light from the sun directly enters the ocean vertically. There's more light rays entering per square area. Near the poles, the light enters at an angle. There's less light rays per area. They're entering at an angle. Some of that light is reflected off. And at the poles, there is ice, which is very shiny and white, and it reflects a lot of light off, rather than blue ocean water where the light goes in and heats up the water. So there's a number of reasons for that, but you can see there's dark blue and purple, magenta closer to the poles. Well, what's interesting is looking at the temperatures of the ocean over time. So we're going to look at the first full year that they recorded, which is 1982. That's the dark gray line at the bottom here. Over the year, in March and April, it's the warmest. I think because a lot of the oceans are on the southern part where summertime is during that time. But there's also a second bump in September where it's summertime in the northern hemisphere. But as you go through the years, so we look at 1990. 1990 is down there. 2000. 2001 is pretty cool. 2010 is getting a little warmer. The temperatures are higher up on the graph. 2020, it's very warm. It's much higher than all the other recordings. And then if you look at the last 3 years, so here we're going to reload this. 2023. Oh, for some reason it won't let me do that. There we go. 2023 is the dark gray line. Um, 2024, which is last year, is the orange line, and this year is the dark maroon red line. way, way above all the other recorded ocean temperatures. But it's a general trend that over time, over the decades, this temperature is rising. This shows that the oceans, which had been soaking up a lot of the heat that has been accumulating, and that amount is staggering. If you calculate how much energy is needed to raise the ocean's temperature by this amount, you might say, oh, well, 1 degree Celsius is not very much, Gooby. Well, the oceans are really big, and water is really good at soaking up heat. So the amount of energy that's required to do this from 1990 to now is the equivalent of 5 Hiroshima nuclear bombs exploding per second, and all that heat going into the ocean continuously from 1990 to now. So 5 nuclear bomb explosions a second is, in 1 minute, is 300 nuclear bomb explosions every minute, every hour, every day, for 365 days a year, for every decade, from 1990 till now. That's how much energy is required to raise the ocean temperatures this much. So what's raising those temperatures that much? Well, it's the stuff we burnt. The gas, the oil, the coal, the natural gas. All that gets released into the atmosphere, and it traps the solar radiation, heats up the air, heats up the surface, the land surface, heats up the sea surface. That makes forests burn. We also cut down forests to make way for agriculture, for growing food and letting cows and domesticated animals graze. So when we burn the forest, it releases more CO2 in the air. There's methane. As things warm up, things that were permanently frozen, like permafrost, like in Siberia and northern Canada, they start to melt, and then the organic matter that was frozen there starts decomposing, and bacteria eat them up and release methane. Now that also goes into the atmosphere and heats things up more. And then there's frozen methane deposits under the ocean. But as they become unfrozen, methane bubbles up from the ocean floor. So it started with us, humans, burning a ton of fossil fuels, cutting down forests, burning them. But it's triggering positive feedback loops of melting the ice on we're going to talk about that, but it's triggering feedback loops that are even more powerful, or they're just as powerful or more powerful than what we're doing, but they're started by us, which is the methane released from permafrost and the ocean floor. The other part of this website that I like to look at is the daily sea ice extent. They have both the northern hemisphere and the southern hemisphere. So, like Antarctica is in summertime right now, and so the dashed black line is the current sea ice extent there, which is low. But it is summertime, but it is lower than, there's half as much ice near Antarctica as there was in 2013. Wow, that's not very long ago. And there's only half as much ice now in the summertime. That's kind of concerning. But in the northern hemisphere, right now is wintertime, and so the ice is the maximum. But in the summertime, it drops way down to here. And so right now, we're at a record low. This is February 23rd of 2025. We're at a record low accumulation of ice in the wintertime. Not boding well for the summer. Now this graph, it stops at 2. So the 0 is one more block down. So far, there's still been a good amount of ice at the polar ice caps, but they're melting. This is 1980, and as you go down, this is 2012 when there was a big storm up in the North Pole. 2020 was this year. No. In general, though, over time, from 1980 to the present, the ice has been decreasing, and the importance of that is two things. Melting ice soaks up a lot of heat. Let's see here. I think there's something that says when you energy melting ice same as let's see here. To heat water. Yeah, okay. When you melt a body of water, say it's a liter of water, a liter of ice, and you put the energy into that to melt it, it stays at 0 degrees because it's melting. It doesn't heat up. It just converts from ice to water. But now that you got water, if you put that same amount of energy in, it raises the temperature up by 1 degree. So we're melting all this ice that's at the ice caps with all this heat, and the oceans have been soaking it up by melting, converting ice into water. But when the ice is gone, then everything just starts heating up even more than it already is. So there's a term called blue ocean event, which means the polar ice caps have melted. And that means that the heat sink is gone. So when this graph ends up going to hit 0, which is down here, because this is 2, 0 would be down where these numbers are. When this graph hits 0, I don't know when that will be, but most scientists believe it will be within 100 years or less. Some say it will be within 20 or 30 years. I don't know. I don't know when it will be. I may live to see it, I may not. But if when it happens, because it will happen at some point, just don't know exactly when, then the oceans heat up very quickly and the climate changes even faster than it is now, for a couple of reasons. We talked about how when ice converts to liquid water, the temperature stays at 0 degrees Celsius. But when the ice is gone, all of a sudden the temperatures start going up because you're heating up liquid water to a higher temperature now. Also, ice is very shiny and white, and so when the sunlight comes in, it hits the ice, and it bounces off. A lot of it bounces off and goes back into outer space. When the ice is gone, now you got blue ocean water. Sunlight will not bounce off of it very much. Some still will, but most of it will enter into the water and then heat up the water. So when there's a blue ocean event, it means our way of life changes very, very quickly, and that will happen within 100 years, probably sooner. Don't know when, but it will happen. And so that brings me to the fact that we are in a 6th great mass extinction. So this is really why I've been thinking about this, is that I think humans somehow, we tell ourselves these stories. Our religions tell us that, some of the religions, not all of them, but some of the very popular religions that are believed by a lot of people tell humans that we are the center of everything. We are the most important species, most important living being. Man and women, humanity is the most important species that ever existed and ever will exist and will exist forever. And that all the other species are for us to dominate over and take care of, or not take care of, just dominate. That's what the more prevalent religions talk about. And it's, even if you're not religious, that's what a lot of our culture thinks, that everything exists for us, that without us there's nothing, which is not true. If you look at this graph right here, this graph shows 3 of the past 5 mass extinctions and when they happened. Now keep in mind, humans have been around for 0.3 million years. The end Permian extinction event happened 252 million years ago. We've been around 0.3 million years. All of a sudden, humans aren't at the center of everything. End Permian extinction. That's like dinosaurs going extinct. Well, at that time, temperatures rose 8 degrees Celsius over 60,000 years. So they rose a lot. 8 degrees Celsius is a lot over a long time, 60,000 years. And 96% of marine species died and 70% of land vertebrates died. I think it's like 90% of plants died. They just went extinct. That means that every single organism of that species died out and they were never to be seen again, like a lot of the dinosaurs and plants that were around at that time. The other 2 extinction events listed here, end Triassic. Temperatures rose 4 degrees Celsius over 10,000 years. 76% of all marine and land animals went extinct. Paleocene, Eocene, thermal maximum, 5 degrees Celsius over 5,000 years. Well, this red line is what we're doing. This is the 6th great mass extinction that has already begun. And it was begun by us. Now, it will probably be carried out after we're gone, because we've kind of set things in motion, but a lot of things we've set in motion will take thousands and thousands of years to play out. And I don't think we're going to be around for that. If we are, it's probably going to be very small groups of humans, if at all. Not 8 billion of us like there are now. So our current rate of temperature rise, we are actually at 1.5 degrees Celsius above the pre-industrial baseline. So industrial revolution started like 1700s, 1800s. So within 200, 300 years, we've already gone 1.5 degrees Celsius. And Triassic went 4 degrees Celsius, but over 10,000 years, and we've done 1.5 in 200 or 300, depending on how you want to define the baseline. And you can see as we keep going, this is what the red line looks like. And we're seeing that in the ocean temperatures. We're seeing that in the atmospheric temperatures. Climate Reanalyzer has surface air temperatures across the whole world. And you can see orange and maroon lines compared to the 70s, 90s, 2000s, 2000 teens, and then now we're way up here. So this is what's happening. And some people don't want to think about it. I don't blame them. This is not a comfortable thing to think about. But I think if you really want to understand what's happening, you have to understand this. This is what is happening. What are the chances? How many species are going to survive this mass extinction? Well, we are speed running the mass extinction program. The red line is way steeper than any of the other ones. So I don't know, but in Permian, 96% of marine species extinct. In Triassic, 76% of all marine and land animals extinct. Well, it certainly looks like ours may be worse. I don't know if it will or not, but at our current trajectory, it looks worse. So let's just say 95%. I'm just pulling out a number. I'm just guessing. Saying it's worse. Oh, actually, it said 96% in end Permian. So let's just say it was worse than that. 98% of all marine species and 95% of all land animals went extinct. What are the chances that humans are going to be in that 5% that survives? And what's life going to look like with only 5% of all the species that are available? I look outside my window, I see trees, I see grass, I see birds, there's squirrels, there's bunnies that live here. What if 95% of them are extinct? They're gone. What's life like? If humans are still alive? I probably won't be alive. Would humans still be alive? I don't think that it is a given. I think this idea that the universe exists for humans is a bunch of baloney. I think we're part of the universe. And we may not be part of the universe if we keep going down this path. We may go extinct, like the dinosaurs, or the majority of dinosaurs. Well, that's why I was thinking about tardigrades, because I think tardigrades are pretty cool. I think that they'd be able to survive. Maybe. The sixth great mass extinction. They may go extinct too, because they eat plant matter, and if most of the plants go extinct, then and their food source is gone, then they go extinct too, even though they can survive, even though they're very hardy and can survive extreme environments. If their food is gone, they're gone too. It may just be Planet of the Tubeworms, because the tubeworms, they literally are just eating nutrient-filled water coming out of the earth, out of the geothermal vents. And that will still be going on. The ocean's chemistry may change. It may make it too hot for them. I don't know. Well, no. They're living next to a geothermal vent, so it's like really hot water anyway. So I think they'll still be around. So this may end up being Planet of the Deep Sea Tubeworms. Well, those are some things that I've been thinking a lot about. And, some people say, hey, Gooby, you worry too much. You should just chill out. I do chill out. And I like thinking about these things because it helps me understand what's happening in the world. And maybe you're worrying too much about me. I don't feel like I'm worrying about it. I'm just trying to understand. That's what I want to do. If it bothers you, maybe ask yourself, what about this bothers me? It is very understandable to be bothered by the fact that humans are driving themselves extinct along with 90% of all other species. If you're not bothered by that, I wonder why, because I think that's uncomfortable. I am part of a species that is responsible for ending the life of probably over 90% of all other living species on the land and in the ocean after all this plays out. That's a pretty heavy thought. And we might probably end ourselves too. That's a heavy thing. So before you attack the messenger, before you write some really mean comment on this YouTube channel, just think about it. Yeah, this is a very uncomfortable thing to think about. But I think it's necessary to think about it if you want to understand what's happening to us. You don't have to. You can stick your head in the sand like an ostrich, and that's one way to live. And that's not how I want to live. Well, knowing this and knowing that, well, I probably can't really change what's happening and the trajectory that we're on, like, what's the point in knowing this? Well, here's what I think is the point, for me at least. Knowing this, I'm not going to waste my time doing a bunch of bull. I'll bleep that out. I'm not going to waste my time doing that. I'm going to live the life that I want to while I'm still alive. I'm going to participate the least possible in this destructive culture. I have to participate some in order to be alive and to have food. I need to pay bills like electricity to power this computer and internet to share this video. This is how I make money these days, is making videos. That's how I'm able to pay the rent for this apartment and have food to eat. But I'm not going to participate beyond that. I'm going to spend the rest of my time with my dog, my wife, my friends, spend time out in nature, spend time caring for myself, caring for my mental health. Not going to spend time with toxic people. If there are toxic people that want to hurt people around them, well, they can do it somewhere else. I'm not going to be around them. I'm going to play music, play with my friends online or in person. I played a really fun board game at a party. I forgot how fun board games are. I played a new one that I never played before, and one of them I just watched, and it was really fun to watch some new friends I made. They're my wife's friends. It was really fun. It was really fun to play games. Like, it's just simple. It's a simple game. No electricity involved. Just humans interacting and playing with each other. It's a good time. I want to be creative and make things, write things. I had been some people had asked, well, how's your book coming along? Well, it's not coming along very well. I have a really hard time writing. I don't know if I think it's a couple things, but I have a really hard time writing over a long period of time. Like, I can write stuff for like an episode like this one, or I think I'm more into, like, I need some feedback that is quicker. I have a very hard time working on a project that goes over years and you don't get feedback, like, at all. It's just like, it's really hard for me to do that. So writing a book, not so good. Writing episodes, good. So I have some ideas about episodes and maybe other things that are like that. That's why I think it's important for me to understand where we are. I'm seeing the way we live, the quality of life is deteriorating. Collapse is not like in the movies where people think that one day everything's working and then the next day aliens have invaded or an asteroid hit the earth or some flu wiped out 90% of people, and then now all of a sudden society's not working, and then now you gotta scavenge and fight off cannibal raiders and all that stuff. A collapse is a very gradual thing that happens over a long period of time, and that's what we're living through. Our quality of life is gradually crumbling over time. And it's disconcerting. This is just what's happening. Just because I don't like it doesn't mean that it's not happening. It's happening. And I want to understand that so that I can choose to live a life that I want to during this time of crumbling quality of life. Yeah. Well, that's what I wanted to say about Planet of the Tardigrades and Tubeworms. I guess tardigrades has a question mark around it because they rely on plants. But they're pretty hardy animals, so I think that they'll find something they can eat after we're all gone. Well, I hope that you have a good day or evening wherever you are and make the most of being alive right now.